Now this is the relationship at the bottom. This is the relationship to estimate the position with respect to Earth using the Euler angles as well as UVW. So UVW we will get from the main function, okay, from the main function which was for the dynamic equation of motion having all the forces and moments. We'll get UVW, and phi theta psi we will get from the previous function which is Euler angle estimation function, and this function will give us rate of change of position with respect to Earth, which we will integrate to estimate xe, ye and ze. In this function we will estimate the xyz dot, that is the rate of change of position with respect to Earth. Then we will integrate in the Simulink block, and after the integration we will get the position of the airship with respect to Earth. So first input variable is required, which is equal to u. So u is from xyz we are accessing, so xyz first element is u. Similarly other elements such as v and w are the second and third element of the, so second element is v and third element is w. So here we need to change w and v. So now we have accessed the velocity component. We also have requirement of the Euler's angles from the airship nonlinear dynamics. This function we are getting output as the rate of change of v dot, which is u dot v dot w dot p dot q dot r dot. That is 6 elements we are getting. Other than this 6, we also getting 3 elements from this Euler's angles function, and this is why after 6 like u v w p q r we are having phi theta and psi, which is we are accessing from the Simulink block, or we will access from the Simulink block. So this is going to be the 7th position for phi, and similarly for theta it will be 8th position of xyz, and similarly the 9th position will be our psi. So phi theta and psi, this is what it is, all required inputs. So now we also have a requirement of the rotation matrix, which convert the body frame position to the earth frame position. So that is what it is. I already have this rotation matrix. I can directly copy and paste it over here. This is the rotation matrix, as you can see here, and it has the requirement of these many components. So I'll just to understand it more clearly, I'll just click on here and add triple dots so that it start with new lines, and another triple dot so that it start with new line. Then over here we can add triple dots. The first row is from here to the first semicolon, and the second row is from here, this point, to the second semicolon, and then this is the third row. So basically 3 rows and 3 columns. Column ends after the comma. So this is the first column, and from here to here this is the second column, and from here to here this is the third column. So what you can do, you can directly type as it is, whatever is given over here from this point to this point, you can type this in your Matlab environment as it is, so that you'll have the rotation matrix. Now we also have required the body velocity vector, so we can say body velocity, and this velocity vector will be equal to, in column format, u semicolon v semicolon w. So this is what it is. Now we have a velocity vector as well as the rotation matrix, which can be useful to get the rate of change of position with respect to Earth. So that is xyz dot. So xyz dot is equal to the RBE matrix multiplied by this body velocity, and this is what it is. Now we are getting xyz dot, and after this we will integrate in the Simulink blocks, and after integration we will get the position vector with respect to Earth.